So hello everyone, nice to be here. So my name is Veli-Pekka Salo. I'm head of AI analytics and automation at Wapice, and here's my colleague Aurelian Pop from Wapice. And we will actually try to hit two flies in the same hit. So we'll try to present two use cases in a row. So the first one is Huhtamäki paperboard cup quality control, and the other is Ware Edge Hub Gateway. And Ware is actually one of our most remote customers. They are from Australia. And just before that, shortly about Wapice. So we are headquartered in Vaasa in Finland, but we are present in all the major cities in Finland, employing some 330 experts at the moment. And we've been part of the OPC Foundation ecosystem, like almost from the beginning. And our journey with Huhtamäki started a few years ago. And Huhtamäki is a Finnish company founded over 100 years ago, listed in Nasdaq, and they have a global operations all over the world. We've been working with the Huhtamäki Nordics, so this is not a global project yet. And Huhtamäki is basically the global market and innovation leader in sustainable packaging. And they are using mostly the fiber, paperboard and flexibles. And flexibles is, like it says, like flexible materials. So the problem statement. So Huhtamäki is, I checked from Wikipedia that year 2017, Huhtamäki was producing 18 billion paperboard drinking cups. So you can guess that there's a lot of those going in the production lines. And every now and then there happens to be some problems. And whenever a problem emerges in the production line, then there can be a lot of material loss. So you have to go into the storage and start finding it. Hey, where did it start from? When did it happen? And this had to be changed because, of course, material loss it's expensive and also produces waste material. So the vision was that how to move from manual visual inspections, batch inspections, and decisions, individual decisions by each operator, to automatic quality detection, continuous inspections, and standardized approved quality. So we started creating the solution together with the customer, and machine vision was the answer. And we joined the customer. We started investigating the setup. We created so first thing we found was that the best way to find the problems was to illuminate the cups from the below. So the customer implemented basically an inspection line. So there's an aperture under the cup. The cup is basically separated every now and then from the production line to the inspection line. Then it goes into a inspection placement. There's an aperture, and then also enclosure around the cup, which then protects from the ambient light and also from the reflections. Then it's illuminated and an image is triggered. And I will walk you through the how to train a custom neural network vision model, because it's not magic. And we started with something between 2,000 and 3,000 images. Well, part of those were used for the training and part of those were used for testing. And the hard work is to do the annotation process, which is basically then doing the labeling. So assigning the category for the defect. And then the bounding box, which is basically a rectangle drawn around the object. And there's tools for this to do this, and that's the hard work that you have to do first. And after that, then you choose a base model, and you train the base model in a forward process. So you make these training epochs, and after each epoch you get a little bit better. And once you've trained your model, you basically get the errors down, and you get the trained neural network model. I can't exactly say which model we used, but for example, the autoencoders, they only use the non-defected images. They learn then based on those what is good quality cup and what is then defected. They did not perform that well. There was some other algorithms that worked better, and as a result, we got almost 100% accuracy. And we actually we managed to beat the customer expectations there. So then comes actually the OPC UA part, and when I was making the presentation, I actually knew that Stefan will have the Swiss Army knife picture there. I've seen it before, and also in this project, the OPC UA, it really nicely enabled us to, both customer and us to focus on different parts of the project. So customer focused on the automation, creating the inspection line. We focused on the AI part, creating the machine vision part, and then it was really absolutely no hassle to combine the PLC connectivity with the camera system. And that's where the OPC UA helped. And we really used only the bare bones there. So you can really choose the best tools from the OPC UA you need for each problem. So I will then next let my colleague Aurelian.
Hello everyone. My name is Aurelian Pop. I'm at Wapice. I've been there for 13 years now. And I will be talking to you about, I will bring OPC UA from a different angle. First of all, maybe let's make a short poll that how many of you have hands-on experience with software development, that have been at some point in your life developing software? Okay, the majority. Okay, good. So as we all know, okay, the OPC UA is a great technology and can be used in very many ways. But important is to have good set of libraries that you can use when you're developing your software, when you're developing platforms whatsoever. So we are going to exemplify this with a practical example that we have had in 2 years ago. Actually, Veli-Pekka has made a presentation 2 years ago in this forum. I don't know how many of you have seen it, but it's about using OPC UA in a mining equipment manufacturing project. So the project was small at the beginning. It has increased a bit over the lifetime. As you can see, we had the goal of rewriting and writing an IoT Edge gateway, which is OPC UA capable. And it was used as an in-place replacement for some legacy solutions that they had made in the early 2000s, which was not developed anymore, and the mining equipment didn't have means to continue development. So they contacted us for that we would like to kind of have a modernized version of that. And we had some milestones there, but basically a little bit of time to make basically a proof of concept, couple of maybe 3 months to rewrite all the functionality to bring it back to what they currently have, and then just a final month to kind of release them. So basically documentation and test reports and all that. A bit about the environment. So as I mentioned, this is a heavy machinery manufacturer. Vere actually is a British corporation, but it has several divisions, and one of them is Vere Mineral, which is headquartered in Australia. So in the mining environment, I don't know how familiar you are, but it's a very dirty environment. And this equipment, this electronic equipment that sits on site is subjected to very heavy conditions like temperature and dust and humidity and all that. So the equipment basically sits in some cabinets that are very well enclosed and air conditioned and all that. So how you can think of these things is that at the very end, on the left-hand side, you have the equipment, and then you have the PLCs and the networking equipment and the gateways and all that in these very well enclosed cabinets that are even having air conditioning. So we were supposed to do this highlighted yellow box there. Think of that as a software that is running inside a small, passively cooled industrial PC. And we have all the boxes so basically the yellow box represents one software item that runs in that industrial PC. So basically it's connecting to the OPC UA, via OPC UA it's connected to the PLCs, reading the symbols. Maybe it has, every PLC would give you thousands of symbols, low thousand numbers, maybe 2,000 or something like that, each of them. And you could get them at various time intervals, like 100 milliseconds, 500, 1 second, and all that. And then we were supposed to ingest this data, save it locally for let's say monitoring purposes, offline monitoring purposes, and then eventually also send it on to the cloud via MQTT. And there was also an interface that the users were able to, that the engineers were able to use to connect to the system, configure it, extract the data for local, mostly for like debugging or kind of when they're doing some special operation that they need to monitor live there on the spot when they're doing some commissioning or something. And yeah, so because we were starting a greenfield project, so we didn't have any kind of legacy or anything like this, we were having the luxury to be able to choose our own technology. And this is where this is kind of the angle that I'm trying to present here, because one of the very important requirements that the customer had for us is that the uptime needs to be 100%. So they do not have time to have this heavy machinery stopping because you're introducing, for example, in the gateway stability problems, all of that. So that has to be 24 hours work, no problem, no questions asked. So we looked around and we were considering Rust as a candidate to try to do this because the project was small in scope. And the main risk that we actually identified was the actual OPC UA support in Rust, because we have never used it before. Rust is rather a new language compared to the dedicated like C and C++. So we were thinking that, okay, we can try to do this, but we do not know if there is good enough support on Rust for OPC UA. But we agreed that, okay, let's try to mitigate that risk by during the proof of concept. And if the proof of concept would fail, we would just say, okay, we go back to traditional and we'll just write the project in C++, for example. And then what were the results? I'm going to skip over all the details, but results was that the support of the library, the OPC UA was quite well matured. I will talk more about it in the following slides, but we didn't have any delays. So that means that everything went like in Strömstad, how they say here. At the end of the project, they actually, because I think that originally they used us as a kind of a benching to see, can this be done? And since it was successful and on time and on budget, they said, okay, we have these more requirements for you. Do this for us. So let's enhance the solution now, because the original project was just to meet the feature parity with the existing solution. So far, we haven't had any problems with that, no bugs. We just had a couple of maintenance releases, mostly adding more logging as a feedback from them. They wanted a bit more events that they would be logged in their systems, so that can be used for for auditing, and then a minor UI-related, let's say, misunderstanding when the requirements were driven, so changing some buttons here and there and all that. And as a bonus point, this is not related to OPC UA directly, but it is a nice story, which we can discuss outside in the booth if you want. We actually caught a 0-day vulnerability that was issued by the authorities the day before our release, and it was automatically caught. So that was a surprise, because at the very beginning we didn't even know what was that, and then we realized, whoa, this happened. So it was a very successful project. I think in my career this has been the most successful projects we had so far. So now let's bring it back into the OPC UA. So this crate, the terminology crate, is what in the Rust world is used for a library. So we use this one OPC UA crate, and the status of that is developed by a single developer, fully functional, at least for the functionality that we required. We didn't need to use very complicated. We had this client-server type of communication with the PLCs. But the development of the library, we noticed it was slowing down. We looked at the release schedules, and they were coming further and further apart. But it had an active community, so that was good, because we saw in the GitHub there a lot of pull requests and all that. So that was giving us confidence that this is good, and it was. We even proposed ourselves we contacted the maintainer and proposed ourselves to become maintainers of this library. We said we can do it, and if he needs help. And originally that was well received by the developer, but then over time, over the weeks, we stopped getting kind of replies, so it kind of got cold. And so this was at the very beginning. This is 2023 autumn, like September, October. But then during the continuation of the project, we noticed that library maintainer was not having too much time we don't know what happened, to maintain it. And the community there present were starting discussion on that project board that they were planning to fork it. And they basically have forked the project under the free OPC UA organization in GitHub, which to my surprise, I found out here this morning when I came that actually you have your own OPC Foundation organization there. So I didn't realize that there are two. But anyway, there's another one, free OPC. They are maintaining other versions like Python and C++. That gives us more confidence in the future if we were to make another project, or maybe even continue this one, if the customer comes back to us, that since it's then maintained by the free OPC UA Foundation, then there could be cross-pollination between the implementations of Rust and C and other languages there. And also, at least this foundation, since it forked the library at the beginning of 2025, they already have made 4 releases. So that's a good sign that the OPC UA is going to be alive also in the next, let's say, in the Rust ecosystem, which is probably going to, hopefully, at least in my opinion, hopefully going to become more important in the future of development, software development. And I think that is all from me. Thank you very much.